First, there was Minecraft Java Edition. Then there was Minecraft Pocket Edition, a little version we could play on our little Sony phones. Eventually, that became Minecraft Bedrock Edition. That was on lots of different systems. But there's a new version of Minecraft that just dropped. It's not official, but it's officially really interesting. That is Minecraft AI Edition. Okay, it's not the real name. It's Oasis. It's a model for generating video on the fly really fast. And when I say on the fly, I mean it. It's like 25 FPS video generation versus less than a frame per second from existing models. And as a result, you can play a game that is being generated on the fly. The results are interesting. So let's dive in. In this video, I'm going to play some of this AI-generated Minecraft. I'm going to explain how it works. Most importantly, explain where this fits in the industry and how it might destroy our conception of video games as we know them today. Stick through, because this is a good one. Before we get there, quick word from today's sponsor. Savala. If you've been around the channel for a while, you've probably seen what we're doing with platforms like Vercel and Netlify and felt a bit jealous if you're in the PHP, Java, Rails, and any of those other worlds. Savala figured this out. They figured it out because they're not just Savala. They're actually another company you might be familiar with, Kinsta. Kinsta has been one of the premier hosts for WordPress for a long time. In order to host WordPress well, you need to do all these things. And rather than just keep doing it for themselves, they've decided to give you access to all of the stuff. And it's good. It's so easy to deploy that I got a Laravel app up in minutes. And by minutes, I honestly mean seconds. I kind of just clicked the button, waited a minute, and it was up. And they don't just use crazy servers that they're hosting. All of the CDN and DDoS type stuff's through Cloudflare. The servers are all hosted through GCP, and it's been a really reliable experience so far. If you sign up today, they're actually offering a $50 credit, so give it a shot if you haven't yet. Thank you to Savala for sponsoring today's video. This is not actually Minecraft. It starts with a screenshot of Minecraft, and then when you move, it tells the AI model, hey, mouse right this long, and it tries to generate the new frames based on that. So now as we go around and I press space, it's guessing what the next frame would look like based on those inputs, which is a kind of nutty way to do something like this. That means that it has no concept of object permanence. It's almost like a 2-year-old. So here you could, let's just find a detail. We'll say these trees over there. So look, there's 3-ish blob trees there. If I look away and now look back, it's something else. And if I look away and look back, it's something else. Because it has no concept of what you were last looking at. It only knows the current frame that you're on. I'll explain how this works in a bit. I want to keep playing first, actually. Let's keep exploring. If you want to see just how weird this is, so we see in front of us, we got those, 3 trees there? I'm going to look all the way down. Now we're going to look back up. And it can be something entirely different. And since everything's based on what you're looking at a given moment, all it takes is one frame with enough data to confuse it to really break stuff. So here, these would block things. If I make that the majority of what I'm looking at, now when I look up, it's going to be like a desert or something. See? Because it uses the current frame's data to determine the next frame. So if you can arbitrarily make a frame useful enough to you, or useless, I suppose, it just changes what's around you. So I lost the desert there because I looked at grass too hard. What happens if I try to break a block? That's actually something I haven't tried yet. Oh, damn. The text is so hallucinated. That's nuts. Ah, yeah, look at that. The hallucinated inventory. The mouse cursor part's particularly trippy. It just hallucinated a pic in my inventory. This is something. Also, just opening and closing your inventory is enough to change what's around you because it covers some of the screen. Oh no, what's happening? What is going on? It froze. I might have broke it. I can't do anything. It's frozen. None of the key presses are working. Okay, positioning queue. We're 12 minutes off. Let's get my screenshot loaded. And while we wait for that, we'll diagram out some stuff. Let's say this box is your game world. And in this game world, we have, I don't know, we'll say that this is a tree. We'll say that we have a house over here, and we have some water over here. We'll fill these so they look a little more distinct. So we got our tree, we got our house, and we got our, let me make it bigger, we got our lakefront. So the way that most game engines work isn't quite as straightforward as people probably assume. I'll say this diamond is the player. So a player has an FOV, a field of view. That field of view determines what they can see. So if this is the player's FOV, then they can see everything in this range. So we can see most of the house, we can see this, but we can't see this. And what happens when you're painting like this is the computer is looking at the stuff that should be visible using a bunch of crazy triangular math bullshit. Based on the coordinate properties of these different things, what should the player be able to see? This has a lot of interesting characteristics. Like, let's say that there was actually another tree here. As long as the house is fully occluding the tree, occlusion is in covering what you can visually see. As long as the tree isn't seen because this is blocking it, most rendering engines are smart enough to not render this tree, because every additional thing you are rendering and creating is more performance and more utilization that your computer needs to do. So now what happens when you turn? As you turn, the things that aren't visible will be rendered or not rendered. So here, the house is still probably blocking this. I'm going to start changing the outline to be dots if it can't be seen. And I'll change the internal color so you can't either. So if we're looking like this, the house is blocking this tree, and my own view can't quite see this one either. So neither of these are being rendered. Their location is known because that's all being stored somewhere. But the actual visual creation of that, going from ones and zeros to actual data that you see, to actual visual images, that's not going to be rendered. But the important detail is it still exists. So as soon as we turn enough, like as soon as we hit here, this will now suddenly become a real object that we can see again. But until it is visible, it stays in that data-only state where it's effectively being stored and saved as data, but not shown to you as a viewer. And the way this works is effectively your data that's being stored in memory, hard drive, wherever, it's being processed by your processor to figure out what's going on and what matters. But what gets passed to your graphics card to actually generate an image depends on what should be visible. Here is how the AI generation is different. Imagine if whenever you weren't looking at something, it didn't exist at all. So instead of occlusion resulting in this thing being temporarily invisible, it means it just gets deleted. Now, when I look this way, since I looked away from the thing, it no longer existed in that moment. And now other things can exist instead. But since I looked away from this, now all of this gets deleted too, because it is only using the data of what you're looking at. Effectively, anything that is not currently in view doesn't exist at all as far as these AI models are concerned. It has no concept of persistence of things that aren't in view, because the way it's generating isn't based on the data of a space, it's based on the data of a frame. So if I have, instead, I know we were just looking at this like as a top-down view, but instead we're going to think of this as an individual frame. So think of these frames as like frame 1, 2, 3, 4, like the actual visuals, the images that your computer is generating. So we have this little tree. This is what we're looking at. Since this is in our view, let's say we turn slightly to the left. This will just shift over because it's in view. But if we turn slightly to the right, we might start losing view of it, and it goes away. Because effectively the model, what it's doing is it's taking this frame and it's saying, hey, move this left slightly. So I just took this random Minecraft screenshot. We're going to throw this into Midjourney. Ignore all of the things I have here. Midjourney is just my go-to image AI tool. What we're effectively doing is this. We are saying, hey, I moved left slightly, or I turned the camera to the left. So we're telling it to generate more data here. And I can do this by doing like that, hitting submit. Prompt can't be empty. Player turned to the left. And it's admittedly a very different, slower model that has very different intended use cases. But we will see what it generates based on me moving the camera over here. See, it actually did a pretty good job. Like, this looks like it could very well be part of Minecraft. You can see if you look closely enough, the texture's not quite right, but it is effectively pivoting over because it is using the original frame as the info to generate the next data. It has no concept of what was over to the right, though. If I re-stretch this over, widescreen Minecraft, I'll say, just to tell it what I'm looking for a bit more, it's not going to regenerate what we had before because that data's gone forever. And you can see here it generated different options based on what it thinks could be happening. So here they had like a hole and a sword on the ground. Here it put some random hallucination. But these other two look pretty realistic. Neither look like what we had before, but it is generating the new data based on what context it has. And the context it has is just the frame. It has no concept of what is where in this Minecraft world. It just has the frame, which is what makes it so trippy to explore. Let's see what happens if we give it a Doom screenshot. I am so curious what it hallucinates here. Oh shit, it's still making sound. I fucking told it not to. God damn it. Thanks, Ark. It crashed. Great. Let's see the gameplay. Let's try that again, because I actually do want to see if this works or not. Hopefully it stays muted this time. No, it did not. Sorry. I bet I lost my spot in the queue. Yep, I did. Of course. Gave it an honest go. So if you understood what I described here with this top-down view, you might think doing things frame by frame is kind of chaotic. Like, why would we ever do anything that way? Well, there's actually a pretty good reason. It's how video encoding already works. Let's say I have a video of me. Let's draw me here at my desk. So we got a little brown desk. We got me here. Let's get a slightly better circle. So this wonderful rendition of me is frame 1. Now let's say we're doing a 30 FPS video. We would need 30 of these just for 1 second. But most of these are going to be nearly identical. Like when I'm here, when I'm looking at you guys directly with the camera, I'm moving a decent bit. But that's what, like 5% of the pixels on the screen, like all the pixels behind me, all the stuff on my desk, my cup here, my laptop here, none of that is moving. It's mostly just me. So why should we need a whole image for every single frame? Because most of the pixels haven't changed. The way that these algorithms tend to work is effectively diffing, which means taking the difference between things. So instead of frame 2 being an exact copy of frame 1, let's say in frame 2, I move very slightly to the side. So I move to there. Instead of it including all of this other data, what it would effectively encode in frame 2 is like little arrows in the spots where things moved. What it's actually going to do is it's just going to encode what changed. So it's going to have pixels for what's different. So it would, if where my side was here is now black, you'll have the black. And if this is now to the side, it'll show that. But each frame isn't going to be an exact copy of the previous frame. It's going to be motion data being applied to the frame, saying, hey, this moved here this amount. That also means it's much better for an AI model because it's significantly less data to deal with and process and work with. So if you take a frame and you say, okay, based on this frame, what should we change? It can generate small amounts of data to apply a change versus, hey, computer model, here is this 3D world that exists. Apply a transform where I turn this amount. That works well for 3D games where you have all of that data already, but it does not work at all for video generation. And this has been tried before. People have tried to make video tools where it's effectively sending you the 3D description of what's going on and where the camera should go, and it plays back on your machine. This was a whole back and forth going on in like the early 3D game days. Like, should the cutscenes in our video games be things that are generated on our device as we play, or should they be what are called FMVs, full motion videos, that are actual video files like an MP4 that is on the disc that plays when you get to that cutscene? The reality is most of the time doing the full 3D generation for complex enough scenes isn't worth it, but this isn't a complex scene. This is Minecraft, which is part of why this is so funny to me. Oh, good info. Thank you guys in chat. Apparently Google did this with Doom already. Real-time recordings of people playing the game Doom simulated entirely by a neural network. So it's funny because my first thought was I'm going to put a Doom screenshot in the Minecraft one and see what happens. You definitely see the hallucinations happening, like when you block something based on your view. It will change. But it's surprisingly close. It even hallucinated like the door requires a blue key. Interesting. Very interesting. I didn't think it would be that far. Also, good question from chat. Would the image degrade to noise if you just shake the screen back and forth? Yes. And I think that's part of why they limit you so much with how much movement you can do. Like I was moving the mouse hard and it was moving like a pixel at a time. it's very, very easy to make it nothing but noise if you're not careful. And this happens with video too. Tom Scott has a great video about video compression, why snow and confetti ruin YouTube video quality. Highly recommend watching this. I've cited it a whole bunch of times, but I'm just going to play this one scene from it. And it's going to be funny because it's going to get re-encoded because I'm playing it on my computer, which is going to encode it. It's going to go to you guys on Twitch, which is going to re-encode it. And it's going to be edited by my video editor, who's going to re-encode it. And then we're going to export it to YouTube, which will re-encode it again. So it'll be great. But yeah, even if you do a high, the point he's making here is if you do a high quality export through your editor, YouTube's quality is still going to be much lower. And then when you're just moving a little bit, like he's just moving side to side here, it's not too bad. But as soon as he starts bringing in snow and confetti, that's a lot more pixels changing, and they're changing really actively. It's the amount of change that causes video compression to be hard, not the like quality of the image, so to speak. Like a really nice, relatively still 4K image is much easier to encode than a 480p video of a bunch of things moving around. And you can see how quickly the video quality goes to fucking absolute garbage as more things are moving on the screen. And as you really increase that movement, like look at this. And here he artificially bumped the bitrate, but it's still, even with just YouTube compression in the highest quality, this will destroy the video quality. Very easy to screw yourself with video encoding stuff. It's actually fun because normally what I do, my videos are relatively easy to encode because I spend most of my time in a text editor. Notice how few pixels are changing on my screen right now. Basically, none of the pixels on my screen are changing at the moment. Pretty much 0 of them, which means it's very easy to encode my video at the moment. But if I was to switch here and move my arms around really fast, suddenly my CPU is going to spike. I just watched it go from 4% CPU utilization to 7 just from that. Like that's the nature of video encoding. It's a challenging problem. I just watched the timer go back up. Counting is hard too. You guys can't see the timer because my face is covering it. I can do that. Yeah. There's a little timer in the corner here. Yeah, if you're curious about the video encoding stuff, I have a whole dedicated video on that as well. Video compression is magical. I loved this video. It bombed initially, but it's slowly been recovering. The fact that you can have a 1080p video with 300 frames that is 1/5 the size of a single 1080p PNG is kind of a miracle. Like the video compression is actual fucking magic, and it's worth trying to understand it, even if you're not a video person. It's cool stuff. Like the fact that we have all of these videos on the internet working as well as we do is a miracle of math and science, and it's one that we should respect and enjoy and embrace. I wouldn't quite say the same about Minecraft AI, but if it's an excuse to talk about video encoding, I'll take it. Oh yeah, the tiniest PNG video. One other that my chat just brought up, this video, 67 bytes, the smallest possible PNG. It's really a breakdown on how PNG encoding works. Worth a watch. Oh god, ask me about H.264 versus H.265 versus AV1 later. We're deep on other things at the moment. We got 10 seconds till this will hopefully work and I can finally play Doom in Minecraft. Fingers crossed. It's unhappy with me. I tried. Turns out it's hard to run Doom in Minecraft. Any of you guys played on the other ones? Are the other ones working? Okay, so this is still my turn. Let's see if the others work. Nope. Rip. Let's see what people have done with it instead. Got teleported to a parallel dimension. So again, remember, when your screen is covered, when you've effectively fully occluded the screen so it can't see other stuff, it doesn't know what to generate for the next frame. So if you give it chaos, like all of these cows that it hallucinated, specifically here, now that it's fully covered your screen, the AI no longer knows anything about the world you're in. It just knows what's in the frame right here. So as it continues to go, it just gets more and more chaotic because it's hallucinating a different world. And it keeps thinking that you're higher up than you are just due to the nature of what you're looking at. And somehow he managed to get to this like all brown wall. God, this is so trippy. The arm just randomly reappearing adds so much to it. Wow, he's really in the void. Do you wake up after or at Skyrim after this? Apparently people are even speedrunning this. I'm so curious what this looks like. What's the goal of the speedrun? Does it show at the end? Is it to get to the nether? That makes sense. So they do that. You have to keep looking at things that can eventually get orange enough that you can make it think you're looking at lava, and then from there make it think that you're looking at the nether. So here, by going into the lava, it's increasing the chances of making you think that, or making the engine think you're in the nether. He almost screwed up there, actually. You can see he looked away a little bit too far, and if he looked any further, he would have lost that orange. Okay. Minute 47 seconds. Can we beat it? It's my turn. What's the most promising start point? Desert Expanse? God, why is it so loud? Okay, if I don't use the bring... Nope, it just crashes every time now. Oh, wait, no. It's working? Cool, it's working again. Cool. You guys can't see the timer. I'm 10 minutes, or 10 seconds, 20 seconds-ish in now. Wish me luck, boys. Infinitely falling. Come on, something yellow. There's yellow over there. Honestly, the strat might just be to spin around until you get yellow something and then go towards it. Look down, then up. Ooh, red might do it. Don't know if that's going to be red enough for me, though. Not making good time. It's harder than it looks. Ooh, that's kind of yellow. We can start from there. Hallucinated us indoors. Good start. Good start. Water's not a good start. Oh no, we lost all our progress. Ooh, we have officially lost the speed run. Fire, fire, yes, fire. No, we're gonna lose it. Yep, we lost it. Rip. I love when it just hallucinates a hand. It's like I didn't have one until now, and suddenly I do. Ooh, this is a good start. No, it's not dirt. It's... I forgot the name of the fucking material. Might be out of luck on this run, boys. Granite, thank you, guys. Oh, it just moved me up way too high. I've definitely lost it now, yeah. Rip. This is quite a run. When I watched that one, like and saw that it took like 2 minutes, I was like, you have to be able to do this way faster. Not that simple. Yeah, there's no way. I got a minute 30 left. Can I do it? Yeah, this just makes me feel bad for the children. Like, so much of the AI-generated bullshit is targeted at kids. Like, I'm sure we've all seen some of the, like, TikTok AI slop. I hadn't thought about that as, like, games. Like, what if those crappy, like, mobile game ad games are real and they're just generated really poorly by AI and, like, force kids to play them? Remember all those, like, tales that we would hear as kids of like the Pokemon that was hidden under the truck in the certain place that was like playground, like fairy tale stuff? Now, if games are actually generated like this for children, oh God. Just imagine like the crappy movie tie-in games that exist. Like I'll never forget Jimmy Neutron PS2 game. Yeah, I remember this absolute garbage dumpster fire of a fucking game that like barely functioned. That was just a like movie tie-in, and this existed to help the brand of the company, not for people to actually play it. There's also the Rocket Power PS1 game. Oh man, this is probably the worst video game I've ever played. It just like, it didn't function. It like, this looks lame. I promise you, it's even lamer than it looks. Like it was if Tony Hawk had all of the fun removed. Absolute garbage. And I think things like this are the future of games for kids. Right now, all the kids just play Fortnite. and they put all of the brands into Fortnite because it's cheaper. But all the companies that are doing these tie-ins, like Nickelodeon and like Cartoon Network and Disney and all those companies, like their goal isn't to make great games. Their goal is to maximize the amount of money that they're making on their IPs while minimizing the cost to maintain them. They don't care about games at all. I could definitely see a future where they use AI tools either to skin an existing game with their assets or just generate new ones on the fly based on what's popular. This has disaster written all over it if it gets reliable enough to do those types of things. So, yeah. There's a lot of things that are popular and garbage, especially for children. I'm mostly concerned for the kids. I don't think that like adults are going to be playing all sorts of AI generated games. I think kids who don't know the difference are going to have this stuff shovel fed to them. Like I still remember like many people don't recall how bad things were in the Atari era. This is a common myth that turned out to actually be true. So the Atari sold better than anyone expected. It was the first major home game console. And Atari didn't pick which games were published. It was a kind of open standard, so anyone could publish games to Atari without Atari's permission. And the result was there were just bins full of garbage games for the Atari. And there was no culture around like reviewing them and figuring out which ones were and weren't good. People just bought the game that had the like characters they recognized on it. So when E.T. came out, an E.T. game was rushed out, and the E.T. game is notoriously one of the worst pieces of video game history. It's so comically, hilariously bad. It's so bad. It's so bad that they made way too many copies, and thankfully, because it was so notoriously bad, nobody bought it, and they straight up had to bury hundreds of thousands of copies of it in a landfill in New Mexico. That's how bad shovelware games were before. Nintendo's big innovation was you couldn't just make a game for the NES. They were very strict about their trademark, about their publishing, about all of those things. In order to get like the Nintendo seal of approval and to be an official NES game, Nintendo had to approve of it. I'm scared that the AI stuff's going to push us back in this direction, especially for the children. And that's all I can think of. And as silly as it is to start with Minecraft, it also shows why I'm so scared, because the children love Minecraft. The children yearn for the mines. And if those mines are AI generated, it's just slop. So this is the model that they were using. It's Oasis, a universe in a transformer. We're excited to announce Oasis, the first playable real-time open-world AI model. It's a video game, but entirely generated by AI. Oasis is the first step in our research towards more complex interactive worlds. It takes in user keyboard inputs and generates real-time gameplay, including physics, game rules, and graphics. You can move around, jump, pick up items, break blocks, and more. There's no game engine, just a foundation model. We believe fast transformer inference is the missing link to making generative videos a reality. Using Descartes' inference engine, we can show that real-time video is possible. When Etched's transformer ASIC, Sohu, is released, we can run models like Oasis in 4K. Interesting that they're doing a ASIC. If you're not familiar with the term ASIC, it is a processor built to do one specific thing really well. They got popular during the early Bitcoin mining days, but they can be used for all sorts of things like this utter fucking chaos. So what they're being used for here, theoretically, is to take the things that this model needs and do them much, much faster so they can theoretically do them at 4K. It will still hallucinate just as much, but at least it'll be more pixels. Interesting. I was going to bring up Sora, which is the OpenAI video model. Oh, look at that. Just like I described, it uses the current frames and then a diffusion transformer that takes in the user input to predict what frames are next. In contrast to bidirectional models like Sora, Oasis generates frames auto-regressively with the ability to condition each frame on game input. This enables users to interact with the world in real time. The model was trained using diffusion forcing, which denoises with independent per-token noise levels and allows for novel decoding schemes such as ours. We train on a subset of open-source Minecraft video data collected by OpenAI. Interesting that the video data was collected by OpenAI for Minecraft. There are few things where there is more data you can use than Minecraft. Like, we probably already, just those two playlists are probably thousands of hours of gameplay. It's nonstop. The sheer amount of Minecraft gameplay that exists is fucking hilarious. I would argue that the only thing there's probably more of on the internet than porn is Minecraft gameplay. I do want to keep comparing to Sora, though, because Sora did some very interesting things. I thought this was confirmed before. I guess it's not. Many people have been theorizing that Sora, again, OpenAI's video model, was actually trained on Unreal Engine 5. Not as in, like, they pointed at the code of UE5 or that they even, like, gave it the engine. But since with Unreal Engine, you can generate a world, which is data that represents what things are where. And then you can do something much cooler, which is create an infinite number of videos of that place by just moving the camera around in many different ways. You can now take one world and generate thousands of hours of video from it that you can throw at your model. And theoretically, now it can have enough data to know the different ways cameras move, and if you move around an object, what it's supposed to look like. And you can tell because a lot of the motion and a lot of the example footage they have is stuff that you can't really do IRL that would make a lot of sense in a game engine. Like this one. Kind of looks like drone footage, but the smoothness of the camera tilt suggests otherwise. And a lot of the stuff that we've seen it generate, I'll just be honest, the person who does a lot of Unreal Engine and game engine stuff just for fun, it has a very UE5 look to it. Like this guy. Just this just looks like you turned up ray tracing too high. So we have some confirmation from chat from somebody who has a friend working on Sora that believes this is correct. There's a lot of info, a lot of people that suggest this is very likely how they've trained it. So it makes it even more interesting that it seems like they're not doing that here. It's also interesting that they called out their goal is to have temporal stability. So again, if you look away and look back, the thing you were looking at before will still be there. That's not what I experienced when I just tried it, but they're trying to make that happen. In autoregressive models, errors compound, and small imperfections can quickly snowball into glitch frames. Solving this requires innovations in long context generation. We solve this by deploying dynamic noising, which adjusts inference time noise on a schedule. Injecting noise in the first diffusion forward passes to reduced error accumulation. Interesting. So they intentionally add noise and reset the noise after a certain amount of time to keep you from getting trapped in noise hell. Very interesting. You guys know all the stories of people who have a memory error in their codes. They just set it. God, I remember one. Somebody had a server that was out of memorying every 2 days. So they took one of those automatic light controls. That's an outlet that has a little timer thing on it that you set to power on and off your lights. And they put their server on that so it would turn itself off every day in order to prevent the memory from going out of bounds, which is just hilarious. This is effectively that, but for the noise in your frames, which is really funny. Also, a good call out here is their model generates frames significantly faster than others. Like Sora, I've heard horrifying things for how slow the render times are. Sometimes it can take a day to do a 10-second video versus them, they can do 25 FPS. That means it can almost be real time. As they call it here, they still need custom hardware in order to make this cost effective at scale, because I'm pretty sure each user, when you play that, is getting a dedicated H100. How expensive is an H100 GPU? Yeah, you're borrowing a $25,000 GPU for 5 minutes whenever you do a run on AI Minecraft, which is kind of hilarious. There are difficulties with the sometimes fuzzy video in the distance. Motherfucker, it's more than sometimes. Precise control over inventories. The inventories don't work. It's a bit bold. These, I feel like they're the ones hallucinating right now when they think it's not that big a deal. It's so far. It's so far. This is a comment from somebody on HN being skeptical. I don't see how you design and ship a game like this. You can't design a game by setting model weights directly. I do see how you might clone a game, eventually without all the missing things like object permanence and other long-term state. But the inference engine is probably more expensive to run than the game engine it somewhat emulates. What is this tech useful for? Genuine question from a long-time AI person. I'm not going to read the answer. I'm going to do my own theory. So with something like Minecraft, that's all just pixels and blocks, obviously, this isn't better than just running it on your own GPU, especially when you consider the fact that this has to run on a really powerful GPU instead. You could just run Minecraft remotely and it would be a much better experience. But that's assuming that the thing that we are generating new frames of is something that any computer can render. If it was something that was way higher quality, if it was something that had insane levels of, everyone's favorite buzzword, ray tracing, that couldn't run on any GPU traditionally, this is a different way of doing it. The same way if we go to what I was drawing here, before we had the ability to do B-frames and frames that had motion data instead of full frames, back when video was every single frame being encoded, we could only go up to 480p. But once we introduced these new ways to encode and decode video and these new compression formats and methods, suddenly we could do video up to 1080p, up to 4K, up to 8K, and even higher. If we think of this as a method of exponentially decreasing the power needed over the quality of the image, where Minecraft and Crysis are effectively just as expensive for that model to render. That's what's interesting here. The barrier we have now of the amount of things you can do in a game engine being limited by the user's GPU is fundamentally different if instead of it being generated with all of the data of everything going on in the world is generated based on the frames that you're looking at. So for a game that's easy to run, this is way worse. But for a game that we can't even fathom right now because it's impossible to run, this would perform fine. Let's see what the developer says instead. They said yep, which is a weird reply to this. There's no question here that you can say yep to. Regardless, let's read the rest. Which is why a key point for our next models is to get a state that you can code a new world using prompting. Like they have code and prompting in quotes. Apparently their goal is so that you can create a world with a prompt and create a game with a prompt. Kind of crazy. I agree that these tools become insanely useful only once there's a very good way for creators to develop new worlds and games on top of these systems, and then the users can interact with those worlds. At the end of the day, it should provide the same API as the game engine does. Creators develop worlds, users interact with those worlds. The nice thing is that if AI can actually fill the role, then it would be, 1, potentially much easier to create worlds and games, and 2, users could interact with a world that could change to fit each game session. This is truly infinite worlds. I did my best to steelman this, and they're making it very hard for me. Quantity is not better than quality. We've learned this over and over again in the gaming world. Here's an example that is partial to my heart. You guys might have heard of Starfield. If you haven't, leave a comment, because I want to have more proof that people don't actually know about Starfield. Starfield is a game by the people who made Elder Scrolls. They have been trying for a long time to see how much stuff they can stuff into one single game. And the result is you can put a lot of things into a game if they are literally just walking around an empty fucking world. It is one of the worst games I've ever played. Not because it's like so broken it's bad, or because it's like offensively terrible or the gameplay doesn't work. It's bad in the same way that like a stale waffle is bad. But now imagine you have a fridge that's entirely full of stale waffles. Like theoretically you could live off of that, sure, but it's a bunch of stale fucking waffles. And it's so embarrassing. So this is supposed to be an important cutscene with two main characters talking to each other, looking at each other directly. But instead of showing that, since their model for how conversations happen is so simple, so they can stuff as many in as possible, whoever's talking, it just centers in on them, and the other people don't even exist. And it will like bug out randomly too. Like somebody at some point here like walks up too close, and it gets super fucking awkward. They just like stand there and stare because they don't know how to turn off their fucking interaction model when these things are happening. Versus Mass Effect, and this isn't the remaster, this is the 2010 version. Just like the difference in like camera angles in the scenes and actually thinking through like where things are placed and the relationships between them. It's actually done with some amount of care and thought. It's fucking hilarious how big the gap is there. To go a little deeper in Mass Effect lore, Mass Effect 1 had a thing called the Mako, where you could land on planets. It's like, well, these are space games. You're supposed to explore the universe. And in Mass Effect 1, you could land the Mako on a handful of planets and explore them. But since these were meant to be like these big planets to explore, they sucked. There was nothing in them. There was nothing to do on these planets, and they were the most hated part. They were so hated that they removed it entirely from Mass Effect 2 and 3 because they learned the lesson. The same thing happened with No Man's Sky because No Man's Sky promised an infinite universe, and everybody was so hyped with this idea of a universe you could explore forever. Who cares about how much you could explore if there's nothing to fucking do? The magic of exploration isn't how many things there are to explore, it's the quality of the things you discover. And that quality is missing when you expand to have these giant universes. And obviously, everything becomes an Outer Wilds plug. There have been like 5 times I wanted to plug Outer Wilds during this. What's funny with this is, I won't spoil the mechanic, but in Outer Wilds, there's a mechanic that's very similar to the way the AI hallucination from the beginning of this video worked. Let me know in the comments if you know what I'm talking about, but don't spoil it for people who haven't played. Play this fucking game. If you take anything from me, if you trust my opinions on anything at all, and you're vaguely interested in video games, please play this game. Ideally not on the Switch. The Switch version doesn't run great, but on everything else, it's wonderful. This is the best game I've ever played. It is very important to me. The less you know going in, the more magical of an experience you'll have. But the solar system in Outer Wilds feels really big, but is really small. And every one of these planets can be explored. And most of them are mostly empty, but the parts that aren't grab your attention and have so much thought and care put into them. It's so good. It's magical. And once you've played something like that, the promise of infinite worlds that was made here, this isn't a real promise. That's not a good thing. Like, nobody wants this. These games don't do well. We give them up in favor of the ones that have more thought and care put into them. That's not where I see the potential value of this tool. But this is a problem that happens a lot with these VC things. And you guys know me, I'm not the anti-VC person. A lot of people like to assume that if they take this thing they don't understand and make it 100 times more efficient, that it gets better. I see this a lot with people building tools for YouTubers. Like, oh, I'd be a YouTuber, but it's too hard. If only the tools were easier, then I would be a YouTuber. There'd be so many more YouTubers. The hard part isn't the fucking tools. The same thing with code. It's like, well, if it was easier to code, everyone would be a coder. We would have so many more things being built, but I couldn't figure out how to code because it was too hard. You're not a good person to make AI code tools if you think that. If you think that what gamers want is infinite worlds, you shouldn't be making tools for game devs. If you think what software developers want is infinite code generation and infinite features for their apps, you shouldn't be in charge of software developers either. If you think what YouTubers want is a magic tool that auto-creates their videos for them, stay the fuck away from YouTube. Stop trying to automate things you don't understand. Focus in on the things you're actually good at and make solutions to the problems that you have within the things you're good at. I'm sad because there are cool things here. Like, genuinely, I see a lot of potential with what they are exploring here in terms of generative video processing. But as a way to create games in infinite worlds, fuck no. You're automating the process of making terrible games. And all this is going to be is brain rot for kids. And that's my biggest concern, is what we are selling here as a noble goal to make infinite game generation is actually going to be a slot machine for children. Until next time, peace, nerds.